idea of the film is to highlight different research topics across the university.
Oh yes.
And possibly to bridge between different fields.
Uh-huh.
But Sasha, what do you think? Why this interdisciplinary stuff is important?
Because sometimes you might realize that you're waiting for the solution of a problem which might be around for already 10 years.
We had this network of early career research fellows. All 10 of us would learn something about all other disciplines and try to think how you can integrate the information you've got and the logic people are using in your own workspace.
This project for me was a huge opportunity as someone new to the university, just to get to know people, to be honest.
I think it's actually really difficult. I think part of this project is to, I guess, to learn from all of you guys about what is a better way of doing it.
At the end, we would have 7 or 10 episodes from each respective disciplines, and this film is the collection of these dialogues.
It's great that this film is taking a real focus on it at the University of Edinburgh.
That was one of the fun things about this project, is getting to go into the bowels of the physics lab and up into IGMM and to see some of the different departments.
You know, there's an awful lot of great interdisciplinary work going on at the University of Edinburgh. You see that in the courses that are provided. You know, there's a wonderful course in music and acoustics and physics that's been very successful and going for a number of years now. So this idea of artiscience, of art and science, of being a discipline within itself is something that's very powerful, and it's actually something that is being taken very seriously at the University of Edinburgh. So I'm involved with helping to develop a master's programme in art and science, artiscience if you will. This is going to be a hybrid between an MA and an MSc, so an MASc programme. So we will attract people from both the arts and the sciences backgrounds onto this programme. It's currently being developed by members of staff in the Edinburgh College of Art and Edinburgh Neuroscience. Edinburgh is an extremely fertile place for this type of thing to happen, especially at the University of Edinburgh. The idea that we are working towards a formal master's programme in the field is something quite significant.
It's a great pleasure that I would like to welcome you to the Exodus Lab, so do come in.
So was there some policy that made you put the lab at the absolute upstairs end of the building from your other room?
No, well, it's just the space that was available. But as you can see, we've got the original fume hoods from this was a laboratory as part of the university.
Yeah, sure.
The veterinary college. And it's since been used as an artist studio, so you can see there's various bits of paint sort of up the wall and on the floor, so it's ideal now that it's something in between. So this will be a permeable membrane between academia, research and the rest of us, somewhere where ideas can flow both ways and engagement can happen in a hands-on way.
I think about the drive to discover things. I remembered a line from a poem by Anne Carson, the classicist and poet. There is something you should know, and the right way to know it is by a cherrying of your mind. Scorch is not the way. And it seems to me that everything we do at universities and in industry is driven scorch, scorch, scorch. I mean, it's a neologism, she's made a word up, but that's exactly what you've got to do. You've got to make things up that aren't there, and they've just got to kind of blossom. But that's not always possible in contemporary research because we're driving to find a cure, or there's a competitive drive.
Driving for results.
Yes.
That's what we're doing. We need results, results, results.
And I know your background's in art history. I'm thinking even with artists where there might not be money in it, it's just you and your project. I think there's still something about that stillness and just letting it come, and it might take years. I think Kant had a silent decade, and that's hard to imagine now. But even if you're driven and money's not the issue or competition, just that, there is something you should know, and the right way to know it is by a cherrying of your mind.
Interdisciplinary process, wow, that's a huge question. I know it's something that can often be quite hard to achieve, but I know that it's also something that makes great things possible. And I think in tackling a lot of today's challenges, it's essential as well.
The point of it for me is that people from very different backgrounds, with very different expertise, with very different perspectives, come together and do something that they can't possibly do on their own. So you can generate new ideas and create new projects that each one of us cannot imagine in the first place, and it's a really great way to work together and move things forward.
It is working between disciplines, right? It's just working between fields. And as a neuroscientist studying the nervous system, we are already interdisciplinary because it sort of has come together from different fields. So you have biochemistry, you have molecular biology, you have genetics, you have all sorts of things, physics, involved in neuroscience. And even that, we get very specialized. So we study one thing in the lab. Come on in, there's not too much in here that's toxic, so just don't eat anything. Okay. And you're safe. Yep. So what I'll show you today is we work mainly in our group on Alzheimer's disease. And like Richard was saying about, he studies synaptic function and connection and memory. We study what happens when memory goes wrong, so in Alzheimer's disease. But still, my focus for the last decade has been on synapses and synaptic connections. And one of the most fun things that we do that I'll tell you a little bit about because it has links with lots of schools is we look in human brain at these individual synapses and how they change in dementias and other diseases. And this is a set of drawers of all of our cases, human and animal, prepared for a technique that I adapted for use in human brain tissue. So it's called array tomography. And one of the problems, I'm an anatomist at heart really, I like to look at things with my eyes and then measure them. And one of the problems studying synapses in the past is that they're very, very small. They're about half a micron in diameter. So if you want to look at the protein composition of a synapse and you do a normal stain with immunofluorescence with a synaptic marker and a protein of interest, and then you put it on a microscope, the resolution of the microscope in the Z or the XY direction, the flat plane, is fine. It's about 250 nanometers, so that's good. But in this direction, in the Z direction, it's over a micron. So we couldn't distinguish accurately the synapses in that dimension. So what this technique does is it overcomes this Z resolution confound by physically sectioning the brain into really, really, really thin sections. And I'll show you that here in a second because my student has set it all up. Yeah. When someone dies who's agreed to donate their brain, we have sort of a really sad day and a really happy day at the same time. Because we get really excited. We get another subject and it's going to be really important for the study, but then we're in the hood, you know, with tears because we realize, of course, this was a person a couple of days ago. But what we do is my postdoc Chris or I will run down to the hospital when the neuropathologist has a case coming in from someone who's agreed to donate their brain. So we'll run down to the hospital, the neuropathologist will take out tiny bits of the brain for us from all different regions. Richard talked about the hippocampus, which is important for memory, so we take bits of that. We take bits of the entorhinal cortex, which is important for memory as well. Bits of the cortex that are important for lots of different cognitive domains, lots of subcortical regions. So we take 38 brain regions, we run them back here to the lab on ice into the human room that I showed you, where we chop them into even tinier pieces. And I'll give you, everybody can have one of these and you can play spot the brain. Can you find the even tinier tiny piece? So each of those thumbnail sized pieces we split in half and we put half of it into frozen stuff that we can give to Sasha or anyone else who wants to look at molecular things. And then the half that we're going to fix, we chop up into sections that are about 1 by 5 by 1 millimeter. If you look straight down it, you'll see the little bit of brain, which is sort of a fleshy color. This is the diamond knife, that's the knife face here, and you can see it. I have to get my eyelash out. You can only touch, these are really sensitive, so you can only touch the diamond knife with an eyelash. So anytime an eyelash falls off of someone in my family, I'm like, stop, I need that.
What determines your favorite eyelash?
It has to be nice and long and springy. So here's the, let's see, that's a little bit better. So this is the 6 millimeter diamond knife, and you can see it here down the scope. So what we've got now is this that I'm moving up and down, that's the little block of brain, and what I'm going to do is show you how we section it into thin sections. It makes a really beautiful ribbon, because what we do is we get a three-dimensional reconstruction of this very small piece of brain by cutting a whole bunch of serial sections and then imaging them all in a row. My passion is to learn new things, right? So I want to know how the brain works. I want to know what goes wrong in disease. And to a certain extent, being a specialist, I can do that really well. But bringing in expertise from outside helps me even learn more about this deep discipline. And if we have any hope of translating what we learn, I work on dementia and Alzheimer's disease, if I ever want to take what we learn about the brain and make it useful to society and to people, we have to bring in other disciplines, right? Because I was saying to Colin earlier, I study the brain and very small bits of the brain, the connections that allow learning and memory to happen, the synapses. So I can find out all I want and all that's possible to know about those connections, but to translate that into something useful for people, you have to know more, right? You have to know something about the neck down as well, because if I find something that would really help the brain, but it kills your liver, well, you know, that's really no use.
Focus is also incredibly important. You know, you can't be all things to all men, and actually, even if you're a really collaborative person who wants to collaborate with others, you've got to have a skill to offer. And you've got to have a skill which you are the master of, as it were. That's why people will beat a path to your door. To achieve that level of skill in whatever domain of, say, biomedical science or broader science, requires a kind of focused mind of kind of, you know, what are you about? And what are you trying to do? Not to go in 50 different directions at once.
I think you need to develop your discipline and bring your discipline on. The boundaries between disciplines will shift over time, and I think that's happening now, and it will continue to happen. But I don't think there'll ever be a kind of non-discipline based approach, because there is expertise that's required, and it's a knowledge of theory, concepts and practice, research practice, and they will always be nuanced by different disciplines, but I think the boundaries between them will shift a little bit.
Can these two concepts live with each other? I think they can, because if you have a kind of, quotes, family of experts across the university who are prepared to talk to each other across departmental boundaries, out of this kind of chaos can come something that's kind of quite fun, you know? I mean, I've just met you, I didn't know you were doing epigenetics. I mean, there's people in my field of learning and memory have got sort of super interested in learning epigenetics. I'm not sure I think it's very important, but I mean, you know, I mean, you can persuade me otherwise, you know, and that's you know, I'm a synapse guy rather than a cell guy, so I don't necessarily go along with it. But yeah, that's part of the fun of it, isn't it?
So what are your thoughts on trying to increase evidence-based practice, and what do you think are the barriers between research into the classroom?
That's a really great question, particularly for the field of education, because we have a lot of criticism in education that teachers don't make good use of evidence from the foundation disciplines. It has been suggested that one of the reasons why teachers don't use the information is because the way it's produced is unhelpful to them. So a lot of information about learning, for example, may be produced through experiments that are done in highly controlled settings. And that might be a really great way to understand a mechanism of learning, but it may be of very little relevance or use to a classroom teacher who is working in a different kind of milieu, where almost everything in that environment is something that can't be controlled for. And so there's another school of thought that says if we want to make better evidence-based practice, then we need research designs that take account of the real-world context in which we want the evidence to be used.
Teachers are incredibly stretched, and they don't have much time to go and look at the evidence base and see if there are ways to translate that into practice once they're already trained. One thing that we could possibly do is try to give teachers resources for or time to really rethink what they're doing and to assess what works and what doesn't work.
I think that's a common position that's held, but it's also one that we have to be a little bit careful about, because what makes you think that you know what they need? What makes a psychologist think that they can understand the nature of the demand that the teacher is operating with? And that's where this idea of collaboration and interdisciplinary work can be quite productive, because it's not to say that psychology doesn't have something really important to offer, but it's not just about that teachers aren't making use of it, or that psychologists have to do a better job of translating the theory into action. I think that's what we have been doing for a really long period of time, and that what we should be doing is thinking about the true interdisciplinary nature of doing research together, where we're really, there's much more of an iterative process of understanding the way that we think about problems and then what we need to do if we're going to make a difference in outcomes for children, particularly children who are struggling with learning.
Changing any practice is not simply a matter of applying something that we found out through research. It doesn't work like that. Like, okay, now there is this knowledge, use it, and do something differently tomorrow.
And I think the promise of interdisciplinarity is it creates opportunities for us to think differently and to move away from some of the constraints of the historical and traditional ways with which we've defined our subjects and the ways that knowledge is produced within them. That's what's exciting about the opportunities or the privileging of interdisciplinary approaches.
I would say that interdisciplinarity in the last decades has gone almost universal. There's very few people now that can stick to one little pod or one silo, as the word goes. Interdisciplinarity promises stuff. It stimulates hopes. We hope that at these boundaries, new ideas arise, new ways of looking at things, new perspectives. Sometimes it's friction, that causes a spark. But managing that, negotiating that, being able to work in multidisciplinary teams where you know what's in your head, but the other person doesn't, and you've got to be able to interact. So we're living in a new age, hopefully leading to positive innovations. Back to sort of the school curriculum and through the universities and stuff, do you think that we are producing the kind of mindsets, not only for leadership, but for to be led?
Yeah. I think you can prepare the ground, but some of the things we've found too in some of the research we've done on interdisciplinarity is that even interdisciplinary first degrees don't necessarily produce good interdisciplinary people, and that you actually need a good grounding in a discipline to understand what it means.
The contrast.
Yeah. So almost you can't really start being properly interdisciplinary until, say, master's level training.
Right.
But what you can do at the school stage is keep giving people a good grounding in the basic disciplines they'll need to mix to make something happen. But also, I think the kind of competitions and projects that school kids do where they've got to work in teams and make something happen. You see a lot of good teachers in their spare time working with kids to develop a gizmo or something that it may not be that innovative, but the kids get a lot out of it. And that kind of thing, I think, prepares the mind for interdisciplinarity.
I have a daughter now, her education, she's 9, and her education is very rounded up, but the feeling is that she soon will have to choose her discipline in towards high school and then further on, and in some way limit herself. How does education solve this problem? At which age people should give up, and should they give up their roundness of education?
Well, now you're raising another really important question for the field, and it has a lot to do with how schooling is organized. So if we use selection, and if we have different kinds of schools for different kinds of learners, then that raises all kinds of questions about at which point do we make determinations about the pathways that children should follow. And we also have alternative views that say that actually this is an example of the kind of process that is quite limiting, puts a limitation on what someone can achieve in their life, instead of education being something that can open up future possibilities. So other people would say, any form of selection is a shutting down of opportunity for someone in some way, and that what we need to be encouraging in education is much more open-ended views of learning and of the possibility for someone to develop and grow their capacity to develop expertise in a particular area. Why should we decide about your daughter when she's 9? But we do that in lots of places. Yeah.
Jose is my bioinformatician. You can see out here his band that he plays in.
And you also play in a band which is quite well known locally, and I heard beautiful music.
Since I was a kid.
Do you find it's a distraction or it's somehow?
No, totally the opposite. In a way, at a very basic level, if anything, it's a mental thing. You need to be balanced. So I think it's very good to have a wide range of interests, no matter what you do, because you can always get inspiration from, from looking at flowers, from photography, from music, and anything like that. Music in particularly, I think, is quite interesting when you look at science, because in science we're looking at a wide range of things, most of the things. You tend to focus on one particular area, but you cannot disregard everything else. And with music, it's a bit the same. You're playing with another, in my band, we're 8 people. We all play different instruments, we all play different things. But you need to be aware of what's going on. And whatever you play, it can sound quite good on its own. But you really need to know what else is going. So it's the ensemble what really makes it. And it's the same with a lot of answers in science, I think.
Thing about this super expensive stage is it's all computerized, so that you can have like 50 different cells that you identify on your slide, and you can have it while you're taking a live movie, keep on moving from one cell to another, and then take a stack of like 100 images going from the very bottom of the cell to the top of the cell. So my lab is focused on the nuclear envelope, and so this is every cell in your body has a nucleus, except for actually red blood cells, which start with one and then get rid of it. The nuclear envelope is a double membrane system. There's lipid bilayers that are separated by about 50 nanometers of spacing. And this is the barrier that protects all the genetic material in the nucleus. It's been linked to over 30 different diseases, from muscular dystrophies, neuropathies, dermopathies, cardiomyopathies, bone disorders, fat disorders, and also the premature aging diseases. We have projects going on in the lab ranging from Alex here, who's working on the nuclear intermediate filament lamin proteins. Andrea here is doing high throughput screening on an opera system, which is, he uses lots of robots and things. Natalia over here works on herpes viruses. She's studying the least understood step in the herpes virus life cycle, which is its egress through the nuclear envelope. Then this here is Fu. He's actually dealing with a lot of patient materials. He's looking at the distribution of some of these nets in various neuromuscular diseases. The breadth of the lab goes further in that Rafal is so perfectly, like the only one you notice here wearing a lab coat, like they're all supposed to.
I need gloves.
We're making a knockout mouse of a nuclear envelope transmembrane protein, NET29, which we're hoping will be a model for obesity, because we've found in some human genome-wide association studies that this net is particularly down in certain cases where you have obesity. And it's also one that seems to be involved in genome regulation.
The building that I work in doesn't lend itself to informal chats or finding out what people do. And I mean, we have like annual meetings where people are quite formal and it's not outside our own kind of area, and you pretty much know what each person are doing. And to really be interdisciplinary, I think we need to actually get out of our comfort zone and go to somewhere like neurology or like clinical psychology and like general hospital and other places.
You have to get out of your comfort zone intellectually, and that's a real challenge. You have to get out of your comfort zone in a physical sense, because you have to interact and go and see other people. So it's both of those things.
You want to meet new people and you want to learn new things, but also in my case, like I said, it's practical. We will never solve some of these bigger societal problems in our own silos. So we really do. We have bigger issues. We need to keep other disciplines' expertise to be able to solve problems. We need to keep the the public and the politicians on board if we want to be able to implement some of this good science.
You know, I think interdisciplinarity just for the sake of it isn't necessarily beneficial. There's got to be a reason why A and B coming together would be more than the sum of its parts.
People need to genuinely see the value of it and feel that they can get something out of it.
You know, so it's interesting that we associate funding and public funding with accountability, got to justify this. Yeah. Whereas actually I don't think that's the case in the private sector, because Google, a lot of the big kind of finance firms as well, they actually let their staff have to play and have fun, because they know that's when the ideas will happen, but also when the staff will feel secure enough, they can start to think long term.
Academia is fun in a way, and the whole idea that like fun cannot be serious, I think that might need a bit of exploration.
That's why I'm interested in people who take risks, because it can create something, and it lets things in that wouldn't have been let in when everything was being justified and you were guaranteeing some kind of outcome.
So I think it's an attitude change, it's a cultural change, rather than necessarily about redefining the institutional changes. I think interdisciplinary working is not only a way of working, it's a way of thinking. It's an attitude. It's how we conceptualize our work and how we conceptualize our curiosity. And I think there's no bound to our curiosity, and our curiosity should naturally take us to work with people from all disciplines, because that is when we can satisfy this wide curiosity.
David Lewis, the philosopher who believed in other worlds and argued for them, he also would write papers arguing with himself under a pseudonym. So he published arguments with himself, published contradicting himself, then reproving himself. I wonder whether there's much scope for that in the sciences, and it's risky in the arts and humanities. You're kind of a lone wolf if you do it, but at the same time you give the world something fantastic, and I think it's a fantastic journey for the person doing it. And I wondered how much scope there was for doing that in the sciences, and either are they kind of lone wolves, eccentric people doing quirky things, or would that affect your career or your ability to have funding? What would happen if universities, research institutes actually enabled that to happen, so like a sabbatical year where you just have fun? Or what would you do if you could just have fun and you didn't have to justify it and say it was, you know, medically important, but you just thought it was cool? Like what would people do, and could that be something that's normalised in the culture? Because I think it's more normalised in the arts, because often you're self-financing and often you're driven by some kind of self-expressive. You don't have to be useful, you just have to be yourself.
What's the most kind of off-the-wall connection you've made with someone that's been useful in your work?
Off the wall?
Like something like you met a biologist and that actually helped you, or you met an artist and that actually progressed your work, even if it's just how you think of your work.
That's a tough question. I've never met a biologist actually. Okay, I've met one now.
It's the question that's really kind of bugging me, and I don't know. I mean, do you as working physicists actually care about all of the different philosophical interpretations of quantum mechanics, all of that sort of thing, which in pop kind of philosophy certainly people care a lot about them.
I think there's a huge correlation between philosophy and physics, but the way you approach a problem between physics and philosophy is very different. Mm-hmm. So the kind of feedback that you get from a philosopher about, for example, the fact that you do an assumption, or the way you use a Monte Carlo for so a simulation for your data analysis, that was very intriguing. Okay. And I think that maybe philosophy is the biggest branch that can give
some input. Some
input, yes.
Okay, interesting.
Inductive reasoning says, oh, because X, Y, Z has happened so far, I predict it will happen again. But it's fundamentally flawed. It's not a rational way of thinking. And the classic example is, you know, the turkey that gets fed every morning by the farmer until Christmas Day, when the farmer comes out and kills it and eats it. So just because something has repeated so far, it doesn't mean that we're right about it repeating again or understand the reasons. And the reason we think induction works is because it's worked so far. So there's a paradox, you know, we use inductive reasoning because it's effective. But that itself is an inductive justification for induction. It's a bit like, you know, having a superstitious reason for following superstitions. So all of science works on inductive reasoning.
But it's philosophy, actually. We would believe that the laws of the universe are the same in all parts of the universe. Mm. And, you know, I think, but we have to start with that. If we don't start with that, none of the theories that we kind of live by doing particle physics work?
So what we are trying to understand is how the term epigenetics is something that is on top of genetics. So it's physically on top of genetics, genomic information, and also functionally it governs the access to the genetic information. And I propose to cut it. Small molecules, metabolites, and other chemicals are passing some chemical clues to the nucleosomes inside the nucleus.
It's a double-stranded break.
Double-stranded break. Needs to be repaired. We tried to make RNA probably. So this is a soft copy of the genome. This gives rise to proteins.
These are histones.
These are the modifications of histones. The covalent, the methylation, acetylation, and so on, phosphorylation.
It's fantastic.
One more.
Oh, thank you.
One of the things that we're really excited about was trying to see how we could bridge between different types of science and link those to medicine, and to think about the different types of work that was going on in the 3 different units that we brought together, the 3 different centres.
You get 5 years in which to try and do something, so pick something difficult. And boy, did I do that. It's showing that there is another way of looking at a big problem, mental health. I stand by everything that we found out of that, and I stand by the fact that it's been a huge collective effort between psychiatrists, basic scientists, and yes, there's a bit of translation there too.
But some of the lessons that we understand from cancer can tell us about things to do with mental health. It's the same biology, the same pathways. So we need to build bridges between these different disciplines.
Both a physical and a philosophical joining of those 3 centres. And the only way to do that was to build a building.
We are now being overwhelmed by so much data, whether it's human gene sequencing, whether it's understanding images, and we have to integrate these data for biology, integrate it into pathology, into the clinic, help us to stratify treatments of patients, help to diagnose disease. This requires skills now that mathematicians have, informaticians, people who do machine learning, for example. So already Edinburgh, under Dave Robertson, has formed this network of people working on informatics, and I was invited to the first meeting. So he's bringing together people from geology, physics, biomedical science, from the clinic, who are all getting together to discuss how we share information, integrate that information and get more value from doing that, greater than the sum of the parts.
You must be making loads of documentaries. Thank you for taking the time to sit with us as well.
So did we just start? You're filming, okay.
I'm not here.
Oh, you're not here, okay.
Oh.
And do we introduce people?
I think you.
Okay, we just go straight in. Mm-hmm. Okay. So Peter, can you tell us a bit about your work, the discovery you made about the Higgs field, and how it fits in with the contemporary thinking of physics at the time?
What I did in 1964 was simply to recognize the solution of a difficulty, a problem with a program which had already been started 4 years earlier, which was initiated by Yoichiro Nambu of Chicago University. Of course, at the time, I didn't realize that in Brussels, Broughton Anglais had already done the same thing, but they were slow in publishing. They had really been ready to publish the previous year, I think. I mean, certainly months before, but they held back because they thought they might be making a mistake. I mean, they were people who had been working in condensed matter physics.
Yes.
They have never written a paper on elementary particle physics before, and they thought they might be doing something silly which the experts would know about. So eventually they had the courage to publish, and in fact by the time I had my ideas in July 64, their paper was already on the way across the Atlantic to physical review letters. My paper went to Geneva to the local editor of physics letters and got rejected. Apparently they didn't see that it was relevant to physics. Anyway, so it bounced back, and I was annoyed about this, and decided that perhaps I hadn't explained enough. The original paper was, I think, not much more than one side of A4. Yeah. So I thought I'd better add a few extra remarks about why it might have some physical relevance. And amongst the extra remarks was the remark that there would be sort of residual leftover massive spin zero particles, which then got named after me.
Yeah, that's the Higgs boson.
That's right. I thought, well, these people in Geneva at CERN, I mean, it was somebody along the theory corridor at CERN who said this is rubbish. They probably still won't understand it, so I better send it to physical review letters.
Can you therefore say that your contribution was in part due to you being interdisciplinary, in a sense that you had knowledge both in condensed matter and in particle physics?
That's true in a sense. I mean, I didn't actually have much involvement in condensed matter, but unlike a lot of theorists in particle physics, I didn't regard it as a sort of inferior part of physics. I've for long had good friends who work in this area, and I sort of kept in touch with what they were doing, so I knew what was going on. I had followed what was going on in superconductivity theory, so I didn't have the sort of prejudices which most theorists in particle physics had at the time.
These are some very state-of-the-art photo sensors. There's 8 by 8 channels in here. So what happens is that photons of light will hit this device, and electronics in here will amplify that signal and allow us to detect the light. The idea is we'll have a whole array of these, something like 3,000 of these detectors in our upgraded detector at CERN at the LHC. So if you want to look at that, just don't drop it.
It did actually transform British academia, because people were kind of amateurish to that point, and it really did professionalise. I mean, they really sharpened up.
Yes.
And now, universities will headhunt, teams and put them together and so forth. But we've now gone through 3 or 4 cycles of that, and it's maybe time to look at it again, I think.
And the last ref had an impact category for which you could get rewarded. The trouble was that impact counted for 20% of the score, and straight academic research counted for 80%. If they'd managed it smartly, they would have said, okay, we'll allow some academics to be 100% in impact and others to be 100% in academic scores, and mix the two that way. And I think you probably won't get the necessary traction with that kind of splitting unless you make it 50-50. So if it was 50% impact, 50% academic, and you allowed people to self-select.
It was a huge gain though, because I mean I was on the RE in 2001 and 2006, and I was on the RF impact last time. So at least this time we are talking about impact.
We are talking about
because
it,
previously I wasn't listened to. I was a non-academic in the room, But the problem I've got with the way they did the impact is it has to be tied. A piece of impact can only count if it ties back to a piece of innovative research. At the impact meeting in Manchester, I got a message on my phone that said that one of my companies, which I had invested in an office in Appleton Tower, had just raised $70 million of funding, and I said, this is pretty good, but it can't count as impact because it wasn't based on a piece of published research. And yet, you know, these companies that are spinning out of Edinburgh University are fantastically valuable,
Yes.
and actually we should be trying to encourage them.
That's right.
And if impact means anything, it means that those sort of companies should be encouraged. But we still can't count them because of that
I think
restriction.
one of the things we could do in Scotland is we could declare UDI
Yeah,
on the
yeah,
ref.
yeah, yeah,
we could
yeah.
have a separate,
Yeah.
different kind of ref for Scotland. I think you could have the biggest impact on innovation in Scotland by doing something like that.
Yeah.
And this ref point about communication, you know, with some colleagues, I wrote a book on how to do interdisciplinary research. It's called Interdisciplinary Research Journals, there's the plug.
May we have a copy for
You may have a copy, yes. The reviews said, not only is this an eminently readable publication, it's extremely well referenced and it does all the proper academic stuff, but we weren't allowed to count that for the ref because it had cartoons in it. And,
oh dear.
you know, it was written in a way that said, here's what we're going to talk about at the beginning, and then it said it, and then it
So where in the ref regulations does it say you mustn't have cartoons in it?
that downgraded it considerably. Yes.
Yeah.
Well, good is measured in different ways, but there is also something, you know, there's standards below which we would never wish to fall in terms of doing rigorous work, rigorous science, rigorous social science.
We talked to Peter Higgs this morning, and he basically said he would be in trouble if REF was implemented during his heydays. So, and he's a Nobel Prize winner. So
Current framework is I think a discouragement to people who want to do slightly off the beaten track things. I was an embarrassment to the School of Physics for years. Somebody was responsible for collecting lists of publications for the past few years and so on. And I would say, I don't have any. I've stopped publishing. I hadn't published anything since 1979.
Is kind of blue sky science, theoretical work gone out the window? I would say not. I think it would be very sad to think that we were creating such constraints in our environment that there isn't another Peter Higgs working who will be getting another Nobel Prize for some very, very crucial piece of theoretical work that then required empirical verification that might take decades to come.
If a department is looking to appoint somebody, particularly at senior levels, they want somebody with a good refable record for their department.
Yeah.
So I'm in a social science department. I go into the ref as a sociologist. I don't publish anything in a sociology journal. They wouldn't take what I write, and a lot of the stuff I write is in the comments section of the nature journals, for example. So I'm targeting an audience that's out there wanting to read about practical stuff. I'm not wanting to contribute to the extension of any discipline. And because it's interdisciplinary, you probably have many more potential outlets for what you write. And you probably have to write 4 papers, whereas a conventional academic would write 1. But none of them are in the highly regarded refable journals, which the departments are looking for. So these departments are looking for the discipline specialists when they're appointing new people, and it's a serious problem.
God is a mathematician.
Small question, do you want it to be understandable?
It's good to have some bits that are only understood by people at very sophisticated level of math, and it would be good also if you go on the other extreme, something that is very, very obvious, and possibly with if you have anything to say about other disciplines and links between what you are, like for example, how you imagine your research question in the context of any phenomenon in other subjects.
Guys, sit, relax, give me 5 minutes, I'll be back, I'll bring you. Yeah, just 1 minute.
Yeah, sure. I mean, it's I'm kind of linguist with linguist.
Okay, this is Dima Орлов from Moscow. And this is Victor Пожелтовский. Dima. Victor. Dima. Okay, Dima was talking for
You have some kind of conversation with Higgs. I mean that it was important for him. I mean that, for example, for guys, is it exist or not? I mean that boson Higgs. Yeah, it's important. Or a supersymmetry, it exist or not exist? I mean that they try to find on collider. For mathematics, it's not important. It's I mean that in some sense we are much more free guys. I mean that it's not important for us. Is it exist or not? It's not our question. So our question is just everything is. We start from something very simple like numbers. You believe that there is a 2? I mean, number. Do you believe?
No, I don't.
You don't know. Yeah, but you together. I mean that on this coach, I see two people. Yeah, I mean that this means that for me it's 2 exist because it's if you want, for example, in this room, how many? 7. Yeah, I see. Numbers definitely exist, and after that you can start.
Does that mean that the mathematics is expanding?
Yes.
The number of problems is getting bigger.
It's a big difference between mathematics and physics. So I mean that some people said that mathematics is a part of physics or something like this. It's not true. I had some talk with Ludwig Fadeev. Do you know that it's St. Petersburg. He is some academician, and I mean that guy who is together mathematician and physicist. I mean, and he believed, for example, that physics is finite. I mean that we have a standard model that that maybe talk to is the Higgs. I mean that, and we have some kind of parameters, 21 or something like this. So I mean that and they believe that world can be described completely in some sense. So I'm not sure that it's true, but I'm definitely sure that mathematics it's not bounded at all. Because if you the whole life you do some kind of supersymmetry project, I mean that you write papers, you go to conferences, something like this, but finally they found that no supersymmetry at all. So this means that your whole life, I mean that completely waste. Yeah, I mean that's all. But in mathematics it cannot be at all. So I mean that, and I believe that everything that we are talking in some sense exists. And on the level of Platon ideas, I mean that it exists.
When I was an undergrad, this was in Moscow. So obviously you take a lot of courses. We did a lot of maths. It was not advanced maths. It was never very much advanced, but some of the most valuable lessons I got. And so coming back to this topic that I raised of the whole collaboration thing. So one of the first things that my big maths teacher said, who you probably have heard of, was Kaganski. So what he says is, what's a proof? A proof is an argument that convinces. And this is it strikes me as a very mathematical thing to say, which really emphasizes this collaborative nature of when you've proved something when other mathematicians agree that this is actually correct. So this is the moment at which it becomes established fact, right? So this kind of thinking. And I find this extremely valuable to me. With all of this training that I got in thinking, thinking like a wannabe mathematician. That was really valuable for someone who's really coming from my background is very much in the humanities. I struggled with maths very badly at school, still do. But it was really valuable. But I do recognize that obviously this does not make me a mathematician because I do not have the specialist knowledge. I will never acquire it. I think it's very valuable for other people to know how mathematicians think, because for non-mathematicians, mathematics is the objective science. It's one where you actually have true truths. Again, so in many fields you don't start by kind of assuming this. There are opinions, and then you're.
I think you need a certain kind of leadership. I think it's a different kind of leadership. It's not the kind of leadership that says, I know exactly where we want to go and we're going to get there. It's the kind of leadership that has what I call a high tolerance of ambiguity.
Right.
So you maintain that degree of ambiguity probably for quite a long time into a project. You're not 100% sure where you're going, but you need the person who's in charge to recognize the answer when it comes up and then to be able to deliver on that answer.
And is that nature or nurture? I mean, can you train somebody to be that, or is it just a temperament?
I think it's nature. We've actually done some research on, in the European Commission when their framework research programs went more interdisciplinary, knowingly interdisciplinary, and they had positive programs for interdisciplinarity, and we talked to a lot of the researchers who were funded under that, and one of the most consistent things that came up was it doesn't matter what discipline somebody comes from, whether they can be interdisciplinary, it's a frame of mind. And there's a frame of mind that really goes for the certainty end of the scale with the reductionist, academic, discipline-oriented focus. And you need these guys, but you don't want them in charge.
Where would you find these people naturally? I mean, on the one hand, as you said, for this kind of a leader, you don't want somebody that wants the whole thing codified.
Yeah.
That's probably the accountant or somebody.
Yeah.
Got to have live with ambiguity and flexibility, good interpersonal relations.
Yeah.
Now, on the other hand, you could have the arts person,
yeah.
and I'm thinking of the more extreme arts person who's highly creative and all the rest
yeah.
of it, and will go, anything goes.
Yeah.
So it's sort of something in between, isn't it?
It is, yeah. I think I've been doing this for most of my career, but I don't quite know why or how, but I do remember when I was at school getting the biggest kicks out of joining things up across disciplines. So suddenly in a maths class, getting an insight that what we were doing in trigonometry, algebra and geometry were all kind of different ways of saying the same thing. And said that to the teacher, and the teacher said, "What do you mean?" You know, I didn't get it. But you know, that's been the kind of mindset. So I think I came with that kind of prepared mindset that like joining things up.
I have a personal view, which is that, for example, I would like to see 10%, say, or X%, some small percentage of the population highly interdisciplinary, and all the population partially.
Yeah.
Say 10%, you know, be highly specialist. There's the famous case, which I know that Sasha, you enjoy, I think James, you enjoy, the famous Frank Molina, the first director of the Jet Propulsion Lab, who went on to form the International Society for Art, Science and Technology, and he said in one of the UNESCO journals, if I'm going to have a heart attack, I don't want a generalist, I want a specialist, you know?
But it's important to emphasise that where that interdisciplinarity sits in the hierarchy of a team doing an interdisciplinary project, because my first experience of being, quotes, an interdisciplinary coordinator of a project appointed by ESRC to coordinate a project that was led by half a dozen enormous academic egos in particular disciplines was just a very unhappy experience. And it doesn't really work unless you've got the interdisciplinary person in charge. So if you want an interdisciplinary project, if you don't have an interdisciplinary person in charge of it, and the academic egos underneath, it won't work.
Go out and reach out to different people, like listen to a few TED Talks and like find out whom your colleagues are from different schools.
All disciplines have, in my view, all disciplines have something to contribute to society.
The individual should learn to be self-critical, but sometimes you can't escape from your mindset. So absolutely the interaction with others, with other views, etc. Fundamental.
People may not get along, the project may not progress as you wish, and by the end of the day it is the kind of risk that we have to take. It's not a choice not to take the risk, because if we don't take risks, we'll never get anywhere. So being able to have the courage to take a risk and trying to say yes when people ask you to work together, trying to reach out to people you may not feel 100% sure, but you think they may inspire you. And I think it's that attitude that can take us very far.
Ask questions. You've got to interact. Get out there, see seminars, talk to people, respond to emails, take a chance. I know you have to achieve your goals and you have a project to do, but just finding out what your neighbours are doing in the next lab, even if it's just coffee, even if you're just having a chat, I think that's a place to start.
Smjorach misharu la fabel, grubachals and do selkadel, diorach ageness adja, troy mig melvram horlem agna, hillaveg o alilio, hillaveg o rahui, hillaveg o alilio. Smjorach le klanda welmi, I am a singer on the floor of a bell, bent in a dust of sleep.